So this is the today's topic of discussion. So we will discuss what is linear regression, because I will not go in details regarding this formula and all. Okay, because these things you will study in the statistics. Okay, so what I will do is that I will just show you. I will demonstrate the application aspect, how we apply linear regression for the analysis of our data. Okay, so we'll begin. So general formula for all biochemical estimations. So what we do, see, whenever we go for any kind of biochemical estimation, okay, so we require three things. One is the test solution. So test solution, then second is the blank or reference solution, and the third is the uh, standard solution. So the test solution means the solution where the concentration of a particular analyte is not known, say glucose, protein, okay, cholesterol, whatever it is. Okay, so the test solution is that solution where we are to determine the concentration of a particular biochemical compound. Okay, then third is the standard solution. So standard solution is the solution where concentration is already known to you. Okay. Say for example, if you want to estimate cholesterol in your sample, so you should have a standard solution of the cholesterol where you know what is the concentration. Okay. Then the second one, that is a blank or reference solution. So what is this blank or reference solution? So blank or reference solution is that solution in which the compound is dissolved. Say for example, if you want to estimate cholesterol in the serum, okay, so the serum, the cholesterol is dissolved in water, because the serum, it is, say we can say that 95%, around 95% is water. So we would say that the cholesterol is dissolved in water. Okay, so in this case, when we estimate cholesterol in serum, so in that case we will take distilled water as a reference solution. Okay, on the other hand, if for example you want to estimate a protein and your protein solution is dissolved in phosphate buffer saline, okay, so in that case you will take phosphate buffer saline as the blank solution. Okay, that is called blank or reference solution. Okay, so then after that, I think these things you have already studied in this your UG classes regarding the spectrophotometry. Okay, so many of the estimations, they are done using spectrophotometrically. So details we will study about the spectrophotometry in the coming classes. Okay, so now here what happens, like we have a test solution where we want to estimate the concentration, and we have a blank solution where we are taking that liquid where our test compound is dissolved. Okay, the third is the standard solution where we are taking a solution where concentration is known to us. These three things are required for estimation. Okay, for an estimation of any biochemical compound. So after estimation, say you have done a spectrophotometry. So in spectrophotometry, what happens? You get absorbance. Okay, so here the ABS. ABS stands for absorbance. Okay, absorbance of the test. Okay. Now here, what is it? Say concentration of the test solution. Because you see here in the this first one, test solution, because our aim of this experiment is to find out what is the concentration of a particular analyte in this particular test solution. So after performing the experiment, we will take the absorbance of test solution and standard solution and blank solution. Okay, and then the absorbance of the test solution and the standard solution, we will put in this formula. Okay, concentration of the test solution, that is our aim, is equal to absorbance of the test. Absorbance, it is also called optical density or OD. OD of the test into concentration of standard divided by absorbance of the standard. Okay, so that means uh, now when you put this formula, then you will get the concentration of test solution. So this formula you have come across many times when you have done when you have done different practicals in the UG. Okay, where absorbance of the test, okay, into concentration of standard, because standard concentration is already known to us, okay, divided by absorbance of the standard. So this gives the concentration of test solution. Now, what is the problem with this formula? In this formula, or in this method, if you use this method, so we are using only one standard. So we are using, so for this experiment, we'll be using only three tubes: test solution, blank or reference solution, and the third one is the standard solution. Okay. Now, this formula is applicable that only when our graph is linear. That means if you increase the concentration, okay, the absorbance will increase in this way. That means it is what we call linear relationship between the absorbance and concentration. When you have this much of concentration, so then you have this much of absorbance. When you have this much of concentration, this much of absorbance. So absorbance is this much, so concentration is this much. That means we have understood that the absorbance and concentration, their relationship is linear. That means all the points, okay, they will lie in a single line. So we call this as a linear relationship. Okay. So this formula will hold good only when these two values, concentration and absorbance, if they have linear relationship. But practically what happens, the concentration and absorbance of any compound, their relationship is not linear. That means they lie in this form. That means their relation, now what you can see here is that different points, okay, they are not lying in a straight line. They are in this manner. Okay. So when you have this kind of relationship, when your relationship is not linear, okay, when the concentration and absorbance, their relationship is not linear, so in that case, when we use this formula, you will get a wrong result. The result will be erroneous. Okay. So for that reason, what we will have to do, we have got two methods. Okay. If you are sure that your absorbance and concentration, their relationship is linear, so in that case you can use this formula. Okay. But when you know that the absorbance and concentration, their relationship is not linear, then you should not use that formula. Okay. But in majority of the cases, 99% of the cases or 99% of the test, the relationship is not linear. So the relationship is like this. This is called non-linear relationship. Okay. So now we have another method that is called multiple standard method. So in this case, you have, this is a single standard method because we are taking only one standard solution of a particular concentration. But in multiple standard, what we will have to do, we will have to take many standard solutions of different concentration. Okay. So here we are taking standard solution of only one concentration. Okay. So when we use the multiple standard method, so in this case, we will take more than one standard solution of different concentration. So this is the example. So I'm taking the example of the Lorry's method of protein estimation. So in Lorry's method, okay, we are going to estimate the protein concentration of the test solution. Okay. So we have taken this standard 1, standard 2, standard 3. So 6 different standards we have taken. Okay. And always we have to remember that the standard should be similar to the compound that we are looking for. Say for example, for protein estimation, we always take bovine serum albumin as a standard because bovine serum albumin is protein. Similarly, if you are estimating cholesterol, so you should have cholesterol as a standard. Okay. So same thing is here. So in this case, Lorry's method of protein estimation, okay, we are taking multiple standards. Okay, 1, 2, 3, 4, 5, 6, and this is their concentration, 20 microgram per ml. Standard 1, the concentration of protein is 20 microgram per ml, 40, 80, 120, 160, and 200. Okay, this is the way how we take multiple standards. Okay, after taking multiple standards, and then we take their optical density. Okay, we take their absorbance, and then we estimate, and then we calculate the concentration of the test solution. In earlier, what you have seen is that we have a formula where you will put the absorbance of the standard absorbance of the test, concentration of the standard, and then you get the concentration of the test. Now in this case, you have got many standards, so we should not use that formula. So in this now to solve this problem, what we will do, we have got two methods, okay, by which we can estimate the concentration in the test solution. Number one is the standard curve method. Number two is the linear regression analysis. So that can be done either in the MS Excel or in the R software. So today I will demonstrate in both MS Excel as well as in the R software. So we first discuss about the standard curve method. Okay, fine. So before that, we'll have to discuss something. So when we are using either standard curve method or linear regression analysis, so we take into account two types of variable. Okay, so one variable that is called X variable. So one is called X variable. Okay, so variable that is used for prediction of the response variable. Okay, fine. So that means X variable is that variable, okay, that is used for prediction of response variable. Now, what is X variable in this case? See, in this case, if we just go upside, see, in this case, you have two variables. One is the concentration, one is the absorbance. Okay, absorbance, concentration. Okay, so two variables, concentration and absorbance. Now, what this statement says, if we look into it, the variable that is used for prediction of response variable, and this variable is known. So that means in this case, this absorbance, the absorbance can be called as the X variable. Okay, or it is also called predictor variable, because you have seen that X variable is that variable which is known. Now you see, for test solution, we do not know what is the concentration, but we know what is the absorbance. Okay, so the absorbance will be taken as the X variable because it is known. And then the next is the Y variable. So Y variable, this variable, the variable that is response variable, or that is to be estimated. That means this is the variable which is to be estimated, or this is the variable in the test solution which is not known. So if we look into the test solution, what is known is the absorbance, and what is not known is the concentration. Or what is known is absorbance, and what is to be determined is the concentration. So that is why the concentration will be the Y variable. Okay, so Y variable is the concentration, absorbance is the X variable, or it is also called predictor variable. Predictor, it will predict. Okay, so Y variable that is to be estimated, and Y variable is also called response variable. Okay, X variable that is known. Okay, and it is also called predictor variable, or it is also called dependent variable. So there are different names. Okay, okay. Now you see, this is another example I am taking of the determination of concentration in real-time PCR. Okay, so in the so we have taken the standard 5 number of standards in the real-time PCR and test sample. Okay, so in the standard 1, standard 2, standard 3, standard 4, standard 5. So this is their concentration, 1 nanogram per microliter. This is the concentration of standard 1. Then 2 nanogram per ml, 2 nanogram per ml. This is for standard 2. 4 nanogram per ml. This is for standard 3. Likewise. Okay. In the test sample, we do not know what is the concentration. So our aim of doing the real-time PCR is to find out the concentration of DNA in the test sample. Okay. So then we perform the real-time PCR, and in real-time PCR, we get a value that is called delta CT or del CT. This is, in short, it is called del CT. Okay. So now you see here, what is the X variable and what is the Y variable? Okay. So we have seen that Y variable is that variable that is to be estimated, and X variable is that variable which is available to us. Okay, and which will help us in estimating the Y variable. So that means in this case, the delta ct, this one, this can be called as x variable, and the concentration, okay, will be called as y variable. Okay, so what you see here is that in the test sample, okay, we do not know what is the concentration. That means the concentration is y variable, that is also called response variable. Okay, and the delta ct value, this value is available for the test also. Okay, so we take this as a x variable. Okay, and now our aim is to find out what is the concentration of this test sample. Okay, so we will estimate the concentration of test sample using this value of the delta ct of the test sample. Okay, we will use the, first of all, we will use the standard curve method. So this already I have mentioned. Okay, now what is the concentration of test sample? This is our objective. So you see, we make a standard curve. Okay, so here we have the concentration, and here we have the this delta ct value. Okay, fine. So this is the standard curve we make only for the standard. Okay, see, in case of standards, we have both x as well as y, but in case of test sample, we do not have the y. Okay, so we cannot use the value of the test sample for making the standard curve. We'll make the standard curve only with the value of the values of the standard. Okay, so we'll plot a graph where it will be a graph between the delta ct value and the concentration. Okay, x and y. So this is the graph we have made, standard curve we have made. Standard curve means the curve which we have made from the our standard solutions. Okay, and then now we have to find out what is the concentration of the test solution. Now you see, our test has got the delta ct value of 10. Okay, so that means the test has got the delta ct value. Also our test, our test is having delta ct value of 10. So we draw a line from 10 to this line. Okay, and then again we draw one more line, this one. Okay, fine. This is the this 10 we have, because 10 is the delta ct value of our test solution. We draw one line here, again we draw one more line. Okay, so now this particular point, okay, this is the concentration of our test solution. Okay, so that will be around, say, 5.2, like that. Okay, so that's how we can find out the concentration of our test solution. But this method has got a lot of drawbacks. Number one drawback is that you'll have to make a standard curve like this. Okay, and then see, here I am saying it is 5.2. So just I'm saying, but I'm just guessing it. I don't have any accuracy whether it is 5.2 or 5.3 or 5.1. It may be 5.25, 5.15. I don't know. Okay. Then second thing is, what is the reliability of this value? Okay. How much I'm saying that my test solution concentration is 5.2. So what is the level of reliability? Okay. So if you ask me these questions, I do not have any answer. Okay. So that is why the better than the standard curve is the linear regression method. Okay. So the linear regression analysis method, okay, it is considered better method. Okay. So when in the linear regression method, what you will do, you will have to enter all this value. You will not put the value of the test sample now. Just put the value of the standard, both concentration as well as the delta ct value. Or simply just you will have to enter the values of the x variable as well as the y variable, okay, into the software. Then after that, the software will give you these two things: the value of slope and value of the intercept. Okay, so here this is the formula, okay, where y is the concentration, because you have seen that y variable is the concentration which is to be known. Okay, and this x, so x is the, in this case x is the delta Ct value. So x is the delta Ct value, and the value of the m and c, m is the slope and c is the intercept. This you will get from the this you will get uh, from the software. Software will give you. Okay, so this actually this regression analysis, it involves a lot of formulas, this and that, but I don't go to that formula because everything is done by software only. So we'll just so I leave all these things to your statistics class. I will not discuss about it. Okay, so okay, please let me know. Can you see this? Can you see this Excel file?
Yes, sir.
Okay, you can see. Fine. So you can see this Excel file, right? So here what I have done is that, so this is the standard one, same this thing I have put over here. So this x is your delta Ct, okay, y is the concentration, because x is the x variable which is known to us, okay, and this is the test value. Okay, so uh, can you see the whole of the Excel file, or you are seeing only this table? Manmi, can you see the whole of the Excel file?
Yes, sir.
Okay, fine. So in we can do this in Excel also. Okay, but in Excel it is little bit difficult, and the things are not very good. But still, I will show you. Okay, so just go to in your this tabs. You will go to data. Okay, once you click in the data, so you will get the data analysis. You click here. Okay, so once you click the data analysis, the one box comes out. Okay, now here you click in the regression. Click OK. See, you have input y range, input x range. Okay, so you just click here and then select the y values. Okay, then you click in the x range and then select the x values. Okay, and then you click OK. So after clicking OK, so once you have clicked OK, so you will get this particular table. Okay, so everything is not very much important. So here what is important is that this value. Okay, so this value is the p value. So remember that the p value should be less than 0.05. So let me edit here. So for regression analysis, okay, there are a few things that is to be remembered. The first thing is that the p value should be less than 0.05. Then r square value, okay, so r square value, it should be more than 0.8. Okay, that means 80%. Okay, fine. So here you see this is the r square value, it is 85%. It's okay. Then this is the significance, p value less than 0.05, that is okay. Now here you see these are the two values. Okay, the intercept is the c. Okay, fine. So if you remember, this is the our formula, y is equal to mx plus c. Okay, so what you will do it here, So I'll just copy it here. So, okay. Now you see here, intercept. Intercept is the C. It is the value of the C. And X variable 1, this means it is the value of the M. Okay. So if you remember, the formula was Y is equal to mx plus C. Okay. So now here, in this case, this is the mod. This is the thing that we have got. This is the model. This is called regression model. Okay. Now our aim is to find out the test concentration. Okay. So what you do? See, y is equal to mx plus c. So here m is minus this thing. So is equal to m is minus 0.874. Then into x. Now here the x is the value of the test. This is 10. Put 10 here. Okay. Then plus c. C is 17.36. 17.36. Okay. I put equal to here 8.62. Okay. So here what it means is that the concentration of the test is 8.62. Okay. This is how you find out the concentration. Now it appears to be easy as compared to standard curve method. And also you see here you are getting the value 8.62. Okay. But because by guessing you cannot calculate this up to second digit. But you have but I have done the calculation up to second digit also. Okay. Fine. Now there are another problem is that when you do it in Excel, so Excel does not answer you what is the reliability of this model, because this one, whatever you have seen here, this thing, okay, this is a model which is called regression model. Okay, so regression model means in this case, if I in this particular experiment, if I say regression model, it will be like this: concentration is equal to mx plus c. M is minus 0.874. Okay, then into x. X is your delta CT value into x. Okay, plus 17.36. So now this becomes a formula. Okay. So this formula, this is what we call model. Okay. So then using regression analysis, we have got this particular model. This particular model we have got. Okay. Now the thing is that how if you have multiple test solutions, suppose you have another test. Okay. So where the CT value or delta CT value or X value was suppose 7. Okay. So using the same formula, okay, you can find out. I'll just remove the 10 here and I'll put 7 here. Comes as 11.242. So this will be 11.242. Okay. So this is how you calculate. Okay. So this is the model. But the problem with when you do with Excel, so you have a lot of problems, like you will have to do all these calculations as I have done here. And second thing is that you do not know how much reliable your analysis is. Okay. So for that reason, we use another software that is called R software. So we can do the regression analysis in the R software. So for that, first of all, you will have to download the R software and install. Okay. So after that, you'll have to install another software that is called R Studio. Okay. So the advantage of using R is that this particular software is completely free. You don't have to pay anything. Number one. Number two, this particular software is quite light software. It's very light. If you put it in your computer will not hang. If you use other softwares like SAS or SPSS, these softwares are heavy software and they will hang your computer. So if you are using SAS, then you should have then you will use your computer only for that SAS only. You cannot use for other things, because if you do other things, your computer will be it will hang. Okay. So now these problems are not there in this particular software. Thirdly, this particular software is internationally recognized. Okay. If you do any kind of statistical analysis in this particular software, okay, so it will be accepted by the international journals. Okay. So what you will have to do? So the actual it is written as R. So you just uh, in the Google, you just type R console. Okay. If you type the R console, okay, so you see here it comes as download. There is a link called cran.rproject.org. From here, you can just click over here. Okay. After clicking here, download R. This one, this you can download here. Okay. And after downloading and installing the R, okay, then the next software that you should install is the R Studio. So you install the R Studio. Okay. So now in the R Studio, you have different versions that you can see here. So one is costing $995 per year. Okay. So among this thing, the first one, R Studio Desktop. So this does not require any license. It is free. So you download the first one, free one. Okay. Fine. So after downloading this one, you install it. Okay. Now I will show you how to use the R software. Okay. So I have already installed the R Studio. Okay. So once you open the R Studio, so this window will come. Okay, fine. So if you just type Control L, so all these things, whatever is written over here, these things will it will disappear. All these things will disappear. Just type Control L, disappeared. Okay. Now what we will do for regression analysis, I have made a list of commands. Okay. So this list of commands I will share with you. Okay. So you can just simply load these commands and you will get the result. Okay. So once I give you just a minute. Okay. Yeah. So once I give you the list of the commands, one kind of script is there. So I'll give you the script. You can save this script in your computer. Okay. Then you just go to the file. Let me zoom it. Okay. Fine. So what you do, just click in the file. In the file, you click in the open file, or simply you can also do the Control O. If you put Control O, same thing will happen. Okay, click in the file. Okay, and then you locate where you have saved my script. Okay, so for today's class, I have saved the script here. Academic, then class matter, then PG, then VBC 602, linear regression. So this is the one, linear regression analysis script. Okay. So I select this one and I open. Okay. So this is the complete script. Okay. So remember that in this particular script, you should not write anything. You should not, once you open this script, you better remove your hand from the keyboard. Okay. Fine. So what you will do, now you go to the Excel file. The Excel file. Okay. Now you select this data. Okay. So remember that you should not select the standard, this column. You should select only this column, y and x. Okay, select y, x. Okay, so both of the things should be there. So remember that you should not select in this way. It's a wrong way. Another point is that you should not select this way. It's also wrong. You select from, start from y, x, select here. Do not select the test, only standards. Okay, and then copy. You copied. Okay, then you come to the RStudio. Okay, so now this is the numberings of the commands. Just put your cursor here. Okay, fine, and then you click in the run. Once you click in the run, and then again you click run. So now what you will see is that this is the place, okay, where your commands will be executed. So that means this is your R script, okay, and the below one, this is the place where the commands are executed. So this is your data. Y is 1 2 3 4 1 2 4 8 16. X is this one. So this data is the same data. It is entered into the software. Okay. Now you see, first of all, we will go for the creation of the regression model. Okay. So first is make the, it is written here, make the regression model. Okay. So just put your cursor here. So once you click the run, so it will execute that command where you have put the cursor. So I put the cursor here, make the regression model will run. Okay. So my regression model is made. Okay. Now it is saying that make the log model or log regression model. Log regression model. Okay. So log regression model means many times what happens, the model does not work properly. So in that case, we have to go for some kind of transformation. Okay. That is called log transformation. Okay. So there are different types of transformation. One is log transformation and one is reciprocal transformation, square root transformation. But I've seen that square root transformation does not work. So we use only two types of transformation, log and reciprocal. Okay. So next is we will make the log regression model. Click run here. Okay. Then next you make the reciprocal regression model. Okay. Reciprocal regression model. Place the cursor here and run. Okay. So we have made three models. One is the simple model without any transformation. Second is the log model, and third is the reciprocal model. Okay. So actually, what is log model here? Log model means what the software has done. This software has taken the log value of the y, and reciprocal model, it has taken the reciprocal of the y value. That's it. That is the meaning of the log model and log regression model and reciprocal regression model. Okay. So now we look into the summaries of the model. Okay. How the model looks. Now you see, summary means it is similar to when we did the regression in the Excel. So we got, this is the thing. We got these things. So this is what is the summary. So similarly, you'll get the similar kind of summary in the R also. Okay. So summary of the regression model, that is untransformed, without transform. Run it. Okay. So you just take it upside. Okay. Now what you see here is that I think I'll have to reduce the zoom out so it will be visible properly. Okay. I do it once again. Okay. Now you see, this is the summary of the our without transform regression model. You see here the intercept is 17.636 coming, and x, this is the slope. Okay. If you can see, this is similar to what we got in the Excel. This thing, same thing we have got. Okay, and you see here the multiple r, this is r square value 0.85. Okay, and this is the p value 0.02, less than 0.05. It is good. Okay, now it appears that this model is good. Okay, then we should also see the summary of the log model, log transform model. Run it. It's written here, summary of the log transform regression model. Okay, I run it. Okay, so you see this is the summary of the log regression model. Okay, so let me put the summary of the reciprocal model also. It is the reciprocal model. Run it. Okay, now let us examine the three models. Okay, so this is the model that we got after without transformation. So here you see everything is okay. P value is less than 0.05, what do you want? And the R square value is 0.85. Come to the log model. This is the log transform model. Now here what you see, the R square value is 97%. It is 0.972. Okay, and P value is less than earlier one. Okay, so what you see is that in this case, this log transform model is better than the untransformed model, because in untransformed model the R square value was 0.85 and here R square value is better. Okay, 0.9782. Okay, fine. Okay, now let us look into the reciprocal model. See, in case of reciprocal model, the p value is good, less than 0.05. But you see, the R square value is even less than the untransformed one. It is 0.8. So that is why the best R square value we are getting in the log model. Okay, so so we say that log regression model is better here. Okay, then further, this is the summary we have seen. Now we see the prediction accuracy of the models. So how efficient our models are. So we can see here. So simply put the cursor here and prediction accuracy of the regression model and click run here. So once you click run here, this is the prediction of the untransformed model. So now these are the values which you have got. The 5 values we have got. These 5 values are the predicted values of the model. These are the predicted y value. Okay. Now this thing you will have to compare it with our original data. Okay. If you look at our original data, so here see here what it says, the first value is minus 0.1, but here the first value is 1. Okay, second value is 2, and here second value is 1.4. That means, and here the third value is 6.1, but here the third value is 4, fourth value is 10, here fourth value is 8, here the fifth value is 12.99, here fifth value is 16. So that means in this case, the value that you will obtain, it should be approximately equal to the values which we have in the y variable. Okay, so these are the predicted values and this is your actual values. Okay, so you see there is no regression model which can give you the exact value, but it should be nearly equal to the exact value. I mean, it should be nearly equal to the actual value. Okay, so here it is 1. So the first value should be either 1.1, 1.2 or 0.9. It should be nearly equal to 1. Second value should be nearly equal to 2. Okay, but you see that without transformation, the model does not give a good prediction. Okay, so now we go to the second prediction. Okay, so this was the untransformed without transformation regression model prediction. Now prediction accuracy of the log transform regression model. If I run this one, so now you see these are the 5 values we have obtained. This is for the log transform. Okay, so you see the first value is 1, here 1.1. Second value is 1.6, it is 2. Third value is 4, here it is 3.9. Then the fourth value is 8, here it is 9.2. And fifth value is 16, here it is 14. So it is almost nearly equal. You see the first value is 1.19, nearly equal to 1. Second value is 1.6, nearly equal to 2. And 3.9, nearly equal to 4. So the log model is better than the untransformed model. Because in untransformed model, the first value you got in minus. Okay. Now still we see the reciprocal model. Okay. Run reciprocal model. Now see the reciprocal model is not at all reliable. The first is 1.29, then 1.4, then 2.5. Here it is 2.5 and here it is 4. Okay. And then you see the last value. Last value is minus 39, but it should be 16. Okay. That means the reciprocal regression model is not at all reliable. So most reliable model is the log transform. Okay. So, okay. Then the third way, how we can assess our models by plotting. Okay. So plotting of the models. Okay. So the first is the plot untransformed model. Run it. Okay. I'll have to run it once again. Run it. Okay. Now you see, this is the plotting we have got. This is the predictor. This is the response variable. Okay. Response means in this case, the response is delta CT value. Okay. So here, this is this line that you are seeing. This line is the regression line. Okay. And these are the data points. These circles that you are seeing, these are data points. So here you see, if the R square value is 100%, or if the R square value is 1, so that means all of these points will be in this line. Okay. If the R square value is less, so that means the points are away from this line. Okay. Now let us see the log transform model. Run the log transform model. So you see, this is the plot of the log transform model. You see here also the points are not on the line, but still the points are nearby the line. Okay, fine. And then again we go for the reciprocal transform plot reciprocal transform model. Run it. So you see here the points are far away. So again, if I start from the beginning, so this is the untransformed model where points are very far. This is the transformed log transform model. Okay, the points are near to the line, and this is the reciprocal transform model where points are very far away. So from this again we say that looking into this plot, we say that okay, the log transform model will be the best model. Okay, now so our modeling, the whatever model we have made, now it is clear that log transform model will be the best model. Okay, now I will come to our actual aim. The actual aim of our experiment is to prediction of the target values. Okay, so in this case our target is this one, test. So we don't know what is the value of the test. Okay, so now we want to find out what is the value of the y in the test. This is what we want to find out. So what you will do here, you don't have to put any formula as you put in case of Excel, but here nothing. So here the prediction of the target value first is the untransformed model prediction. In this case, okay, see in whole of the script you should not type anything. Although I have typed because I am a bit expert in this, so you should not type. But you will type only in this line, in the predict line. Okay. So here untransformed model prediction. Okay. So this x is equal to. So here you will enter the value of the test, value of x of your test sample. Okay. So here the value of x in my test sample is 10. So I put 10 here. Okay. I run it. It comes as 8.62. But remember that this particular prediction I have made from the untransformed model. So untransformed model prediction is, we have seen that this model is not good. But The second one is the log transform prediction. So in this case, what I'll do is that the same thing is there. The x is equal to 10. I'll put the x is equal to 10 here. Okay. And I run it. So it comes as 6.37. Okay. So similarly, I have the reciprocal transform prediction. So here x is equal to 10. I put, okay. It comes as 4.16. But remember, from you see, from this thing, this is the value I have got from the regression model without transformation. This is the value I have got regression model with log transformation. This is the value I have got from the regression model with the reciprocal transformation. So we know that the log transform model is the best model. So then this particular value I will take. So my test sample, the value is 6.37. It should be 6.37. Okay, fine. And again, supposing that I have one more test sample where the x value or the delta ct value, it is coming as say it is coming as 4. If it is coming as 4, I just put it over here. This is a log transform prediction. X is equal to 4. And so I get the value. Okay. So now this is the way how we calculate, how you can calculate the this test. Now thing is that, see, I have spoken a lot of things, so it seems that it is difficult, but it is not difficult. I will start it from the beginning. And this time what I'll do is that I'll take another data of the Lorry's method. Okay, I'll take the data of the Lorry's method of protein estimation. Okay, and that data, okay, I will analyze using the same software. I will close it. I'll close it. Okay, so this is the Lorry's data. So you see, I have got 5 standards. Okay, so this is the concentration of the standard. So y is the concentration because concentration is to determine. Okay, so I have taken it as y, and x is the OD value, optical density or absorbance. I written here, and then I have a test solution where I have got the OD value, but I don't have. I want to find out what is the concentration. Okay, so I will open the R software, R Studio. I'll open it. Okay. So now, once I open it, so it will open like this. Okay. Control L, remove everything. Actually, the removal is not important. If you want to keep, you can keep also. There is no hard and fast tool that you will have to remove all these things. So then go to File, then Open Files. Okay. So in the Open File, I will go to that folder where the regression analysis R script is present. PG, then VBC 602, linear regression analysis, and this is the linear regression analysis script. Open. I open it here. Okay. Now I'll go to, I'll copy this, copy. I come here, I put it here and run it. Again, I run it. Now you see, this is the data, my data. I have entered it here. Okay, fine. Now I go for the making the regression model. I just go on, click run. Okay, fine. Okay, so I just do it once again. Run. I've made the regression models. Okay, now I go for the summary of the model. Summary. Run. So I have 3 summaries, 3 models. Okay, so this is the first model. Okay, without transformation. Okay, so this model, the R square value is 0.9695 and p value is good. Okay, Now this is the log transform model. R square value is less here, 86. Okay, this is the reciprocal. R square value is very very poor. So in this case, the best model is the first one. Okay, without transformation, because the p value is good in all the three. P value is good, but the R square value is the best here. But this is not the only way how to check the prediction model. I'll go for prediction accuracy of the model. Okay, so I will just click run, 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 run. So now the first one, this is the prediction accuracy of the untransformed model. This is the transform model, and this is the reciprocal transform model, log transform model. So let me check it quickly. Okay. So the first one is this one, the untransformed model. The first value is 47. Is the 40. Second is 86, 80, 120, 160, then 200. You see that the values are approximately similar. Go to the second one, log transform one. First, here the first value is 52 point something, very much greater than 40, 75, then 9. Here third value is 90. Here the third value is 120. It's a great variation. Then fourth value is 139. Here it is 160. And fifth value is 244. Is 200. It's a great difference. See the third one. This is the reciprocal model. 51, 66. See the fifth one. It is 200. It is 635. So these second and third models are not good. I'll go for the first model. Okay, fine. Then again, the next is I will go for the plotting of the model. Okay, just to check it. Okay, fine. So plot untransformed model. Okay, run, run, run. Okay, so I have got three models. Okay, so this is the first model. You see the first model, untransformed model. This is the second model where I have the predictor, this log transformed model. Here you see the points are a little bit far from the regression line, and this is the reciprocal. See, points are very much far from the regression line. So in this case, the best model is this one. Okay, here the points are very much nearer to the line. Okay, now prediction of the target values. So untransformed model prediction, because this is the prediction is the best prediction. Okay, now you see my test value, the test, the absorbance is 0.0. That means in test the x value is 0.02. Okay, so here I'll put x is equal to 0.02 and I click run here. It comes as 48.68. So that means the concentration is 48.68. Fine. So this is how we can calculate. We can properly calculate the this. We can have a standardization of our standard solutions. Okay, and here this method is quite easy to perform, and also it is more reliable. So here is that when you do the regression analysis, okay, so these plots as you are seeing, so the best plot we have got is this one without transformation. So this plot you should put it in your lab notebook or in your thesis. So to copy this plot, you just click in the export. Okay, either you can save it as image or you can copy to the clipboard. Okay, after if you copy the clipboard, then just copy plot again here, click in the copy plot. Okay, and then you just open anything. You can open a Word file or you can open a PowerPoint. Say in my case, I'm opening the PowerPoint. So I can just paste it here. So you see, this is the plot I have pasted here. Okay, so this plot indicates the how far, as I'm saying that in this particular experiment, I'm saying that the concentration of my test is 48.68. So I'll have to show that how much accurate, what is the reliability of this value. So I'll have to show my model that my R square value was I don't know how much it was. Let me see it. Let me go it back. Yeah. So you see here the R square value is 0.965. That is 96.95%. So that means what is the meaning of the R square? See the R square, if the R square is 1, that means all the values will be on this regression line. Okay, fine. So if the R square is less, that means the points will be very much far away from the line. Lesser is the R square, far will be the points from the line, regression line. Okay, so this value is accurate because our R square value is 96.95%. Okay, p value is 0.02. Okay, and this is the plot. This plot. These three things I'm required to show. Prediction accuracy you don't need to show in your thesis, but you will have to show this plot. Okay, this plot you'll have to show, as well as you have to mention about the R square value and the p value.